Welcome back. This is Applications of Exponential Equations worksheet help for numbers 8 through 15. So again, I'm not doing the problems for you, but this is just for you if you're struggling on a particular problem. As with the first one, feel free to skip around. Just take the problems that you need. So we're going to do problems 8 through 15 here. So here's number 8. You're investing $1,500 at 5.2% compounded continuously. How much money will you have in 12 years? So, all right. What equation are you going to use? There's a key word here, compounding continuously. So compounding continuously, think about what equation that is. It is the amount in the account at any time t equals p e to the rt. Again, e is a number, just like pi. It's an irrational number that keeps on going, 2.71, blah, 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 blah. Don't type in 2.71 though. That'll get you the wrong answer. Use the E button on your calculator. So $1,500, that's your initial amount invested. So that is your P. 5.2%, 0.052 is your R. And compounded continuously, so we're using the E equation. How much money will you have in 12 years? Well, 12 is your T. And when it says how much money will you have, that means that I am solving for A. Solving for A. So this is a lot like the work on the worksheet you guys did last Wednesday and Thursday. You guys should be good to go with this one. But just in case, you have 1,500, you have E raised to the 0.052 times 12. Just type that baby in your calculator. Number 9, ooh, what a fun slide. Number 9, how much money do you need to invest? Ooh, interesting. When you see this, how much money do you need to invest? Right away, you know what are you going to be solving for? You are going to be solving for the P, the principal, the amount that you're investing. You're investing at 2.8%. And it is compounded continuously, and the amount that you want to have is $25,500. So that is the amount that we want to have at the end of 8 years. 8 is our T. Now there's a key word in this equation that tells you what you want to, key word in this problem that tells you what equation you want to use. That's right, continuously. You need to use the PERT equation. So P E to the RT is what equals A. So just plug in what you have. We don't have P, that's what we're solving for. So that's P times E raised to the, my R is 0.028. That's my R. It's not 2.8, but it's 0.028. So 0.028 times 8. And I want that to equal 25,500. So don't let the E freak you out. Just like we keep saying, E is just a number, just like any other number. You're isolating the P. You should notice that P is being times by all of this. So in order to get your P alone, you need to divide by all of this. E to the 0.028 times 8. E to the 0.028 times 8. That got a little sloppy. So just type it in your calculator. Don't evaluate E first and then try to divide 25,500 by that. Don't do that. Just literally divide 25,500 by E raised to the 0.028 times 8. And that should give you your principal. Number 10, if you deposit $4,000 into an account paying 9% annual interest compounded monthly, how long until there is $10,000 in the account? First off, what equation are you using? Think about it. It's not AB to the CX. It's not PERT because it's not compounded continuously, but it's our classic A equals P times 1 plus R over N raised to the NT. Go through and figure out what are you solving for. Or you could just go through and name each number. So you deposit $4,000. Since that's what you deposit, that's your principal. The account pays 9% annual interest. 9% annual interest, that means that R equals 0.09. It is compounded monthly. Compounded monthly means that N is 12 because it's 12 times per year. And how long? Now we've reached the question, how long? how long? Well, that means you are solving for t. You're solving for t. And then how long until there is $10,000 in the account? Well, $10,000, that is your A. That's the total amount in the account. So let's just fill in your numbers here. I want 10,000 equals 4,000 times 1 plus 0.09 over 12 raised to the 12 times t. Now, there's an issue here. We cannot solve this algebraically yet. Right now, we have no way to algebraically get the t out of the exponent. In order to undo exponentials, you need logarithms, which we're doing next. So there's only one way to solve this right now, and that is to graph it. Graph it and see where they intersect. So you could just graph it straight up like it is right now. I'm going to write a little side over here. Go to Desmos. And you could graph y equals 10,000, and then y equals 4,000. 1 plus 0.09 over 12 to the 12. Now, when you're graphing on Desmos, don't use a t, use an x. It won't graph if you do a t. So you can graph this and then look for the intersection. Now, the y of the intersection is definitely going to be 10,000, so you are looking for the x value of the intersection. That would be the time. And since these are really big numbers, you'd really have to scroll out on Desmos in order to see that. If you wanted to simplify your equation just a little bit before, you can. I'll show you that in green. If you wanted to like divide both sides by 4,000, and I'm dividing because the 4,000 is times all of this, I'm solving for the t, so you're totally allowed to divide here. Just might make your life easier. When you divide that, these zeros cross out. These obviously cancel each other out. So really you've got 10. I'm solving for when does 10 over 4, or that's the same thing as 2.5 equal 1 plus 0.09 over 12 to the 12t. And so if you're doing this one, if you're graphing this on Desmos, you would be graphing y equals 10 over 4 or 2.5, and y equals 1 plus 0.09 over 12 to the 12t. So either way, you're literally, actually that'd be a fun exercise. Do both of these and make sure that you get the same x value. Either way, that is the time that you're going to be getting the answer, time. Number 11. If you deposit $2,500 into an account paying 11% annual interest, compounded quarterly, how long until there's $4,500 in the account? So when you see how long, you should immediately be realizing you are going to be solving for t. And that you are going to have to use Desmos or a graphing calculator to find an intersection, because just like on the last one, we don't have a way algebraically yet to get a variable out of the exponent. So which equation are you going to be using? You're going to be using A equals P 1 plus R over N to the NT. And you're using that equation again because we are talking about money. We've got 11% interest compounded quarterly. So just go through and label all the numbers. You are depositing $2,500. So that is your principal. The account is paying 11% annual interest. So 0.11 is your R. It's compounded quarterly. So N is 4. And we're looking for how long. So we're solving for T until there is $4,500. That's the total amount in the account. So just set it up. All right, now you have two choices. You could right away just graph two different equations on Desmos, y equals 4,500 and y equals 2,500, 1 plus 0.11 over 4 to the 4t. You can go ahead and graph those, see where they intersect. Remember, the y of the intersection is definitely going to be 4,500. You're looking for the x of the intersection. And by the way, if you type in exactly what I just wrote to Desmos, it'll not graph for you. You have to put in X. Desmos graphs Y and X. So put X where T is. So you can graph that right away, and then you'll have to zoom out a little bit. You also can, remember, just like the last one, you could simplify your equation a little bit. I could divide by 2,500 on both sides. And then again, I'm not even gonna, this cancels, whoa, I just erased something, that's cool. This cancels, these zeros cancel out. So now essentially I'm doing 45 over 25, which I know you could reduce, but I'm not going to. 1 plus 0.11 over 4 to the 4t. And so in this scenario, it'll be graphing something that's like a little bit smaller, so you won't have to zoom out as much. I would graph y equals 45 over 25, and I would graph y equals 1 plus 0.11 over 4. Very important to put that in parentheses to the 4, and then I would do x. So either way, to solve for time, I'm looking for the x of the intersection of these graphs. Number 12, how much money would you need to deposit today at 5% annual interest, compounded monthly, to have $20,000 in the account after 9 years? So think about which equation you're going to be using. Not AB to the CX, because it's not just a general exponential situation, it's a money situation, and it's compounded monthly, so you're not using the continuously compounded one. You are using A equals P 1 plus R over N to the NT. We're using this formula a lot. Okay, so the question's asking you, how much money would you need to deposit? So what are you going to be solving for? If you said P, you are correct. We are solving for how much principal. How much principal would we need to invest? So we're going to be solving for that. The 5%, that tells me that 0.05 is R. It's compounded monthly, which means that N is 12. And I want to have $20,000 in the account, so that means that A is 20,000. That's the total amount that I want in the account. And then it's after, of course, 9 years, so 9 is my T. So just fill it in, and then let's see how we're going to solve it. All right, so you're solving for P. Think about, what operation do you have to do to get the P by itself? P is multiplying by all of this. And this, although there's a lot going on, it's just going to be a number, like just some random number. So since P is multiplying by all of this, in order to get P by itself, I need to divide both sides by this whole thing. Now, since this is such an ugly decimal, I would not, maybe evaluate, maybe do 12 times 9. Let's see, 12 times 9 is, I believe, 108. But just for the purposes of the drill here, 12 times 9 is 108. So maybe I'll put 108 up here instead of 12 times 9. But don't simplify all of this stuff because it's going to be a really ugly decimal, so just leave it. So dividing both sides, 1 plus 0.05 over 12 to the 108. So literally just type it in your calculator. That's all you got to do. Number 13, if you deposit $6,000 into an account that pays 6.5% annual interest, compounded quarterly, how long until there is $12,600 in the account? So this is another how long, which means you are solving for T. T is up in the exponent. So if you're solving for T, that means, you guessed it, you're going to have to do graphing. So just go through. Oh, wait, first, which equation are we going to be using? Same equation as we've been using. It's interest compounded quarterly, so you're going to be using that A, P 1 plus R over N to the NT. All right, $6,000 is what you deposit. That means that is your principal. 6.5% annual interest. That means that 0.065 is the R, compounded quarterly. So N is 4. It's 4 quarters in a year. How long? I'm solving for t until there's $12,600 in the account. So 12,600 is my A. So just fill it in. All right, so you guessed it. You are literally going to be graphing this. And remember, just like I've been doing on the other ones, there's 2 options. You can graph right away. You can just say, all right, I'm going to graph y equals 12,600, and I'm going to graph y equals 6,001 plus 0.065 over 4 to the 4t. And again, don't do t, do x on Desmos. So you can do that, just graph it and see where they intersect. The y value is definitely going to be 12,600, but you're looking for the x value. If you graph this, you're definitely going to have to scroll out. So just like we did on the last ones, you can also simplify this a little bit. You could simplify this like so. Divide both sides by 6,000. Now, I know that I could simplify this more, but why? I'm just going to leave it like this. I'm going to say, okay, y equals 126 over 60, and y equals 1 plus 0.065 over 4 to the 4t. And instead of t, I'm going to put x. Either way, I could graph these on Desmos. I'm looking for my x value. Last question. When a certain over-the-counter drug enters the bloodstream, it gradually dilutes, decreasing exponentially. You take a 200 milligram dose at 8 p.m. That's our initial situation. And by 11 p.m., and 11 is 8, 9, 10, 11, 3 hours later, so I'm just going to note that. 3 hours later, there is only 75 milligrams remaining. So first thing, we are going to use the info above, and hint, you're going to have to solve for the b first, to write an exponential equation to represent the amount, f of x, of medication in the bloodstream for every hour x after 8 p.m. What equation are you going to use? I'll give you a hint, not the compounding money situations. You're just going to use your traditional classic y equals a, b to the c, x. Now we are going to assume that it is decreasing only once an hour. Like the amount, the exponential is exponentially decreasing once an hour. So right away, the c up there, I'm just going to have 1, or essentially just ab to the x. So use your information above. What do you know? What could you set up? What do you know in the equation? If you're thinking you know the initial amount, you're correct. The initial amount is 200, so A is 200. What else do you know? Well, let's see. You know that after 3 hours, there's only 75 milligrams remaining. So when x equals 3, y equals 75. And you can use this to set up an equation and solve for your b. This is a lot like the question from last week about the Sears house, and also a lot like an earlier question today or on this worksheet where you were solving for a b. So we're going to use one particular situation. We are going to use, let's see, we are going to use 75 equals 200 times b. I don't know what b is. That's what I'm solving for, to the third. So you're going to solve for b, and you should feel pretty good about this. You're going to divide by 200, and then now this cancels. I've got 75 over 200 equals b to the third. What's the opposite thing of taking the third power or raising to the third power? It is raising to the 1/3 power or taking the cubed root. Either way, raise both sides to the 1/3. This cancels out the 3 and the 1/3, so this actually gives us our b is equal to. Now in this equation, because we're going to need to use it, I'll actually solve through with you. So type this in your calculator and make sure you have the 75 over 200 in parentheses. And then again, if you have an older calculator, you're going to have to type in the 1/3 in the exponent. That should also be in parentheses. But I am getting b is equal to 0.7211247,852. I'm just going to we're going to do 4 decimals. So 0.7211. That's what we'll go with. So for this, we're losing some space here. The whole thing was you're supposed to write an equation. So let's actually write an equation. I'll put my answer in purple here. So they said to do it f of x. Remember, f of x, that's just y. So I'm going to say f of x is equal to, your initial amount hasn't changed. That's still, it's 200. But now I know what the b is. The b is 0.7211, and it's all raised to the x. So x is the hours after 8 p.m., and f of x is the milligrams of this medication in the bloodstream. So there's part A. Okay, part B. If the drug is only effective with at least 65 milligrams in the bloodstream, about what time should you take another dose? So interpret this a little bit. Where are you going to be putting the 65? 65 is the amount in the bloodstream. So that's technically the f of x. So if I'm just going to rewrite my equation here. Rewrite your equation from part 1. So I'm looking for what time, which means I'm going to be solving for what? I'm going to be solving for an x. I'm going to be solving for x when y is equal to 65. So I think you guys can take that from here. You got to keep in mind, though, there's only one way to do this right now that we have, and it involves graphing because you're solving for something that's up in the exponent. So go for it. Part C, assuming that you don't take another dose after 8 p.m., how much would be left in your bloodstream after 10 days? This is pretty simple. We are looking for an f of x. We are looking for an amount after 10 days. The only trick I'm going to tell you is notice on our equation, x represents every hour after 10 p.m. So the trick is that 10 days, okay, well 10 days is how many hours? Let's see, there's 24 hours in a day. Therefore, 10 days is 10 times 24, or 240 hours later. So you guys are going to be finding the amount in milligrams that's left in the bloodstream after 240 hours. Go for it. You got this.